Evet, hepiniz hoş geldiniz. Ee, Dersimiz Math 401 Probability Theory. Let me tell you the textbook that we will follow. You may find this in the bookstore, Elements of the Probability Theory. Second edition. Second edition by Hayri Körezlioğlu, Azize Hayfavi ve Yeliz Okur. Okay. Of course, any other textbook on probability theory can be used as a reference book. I guess most of the topics we will cover in this course is common, material for all textbooks on the, on probability theory. I guess I sent you the course syllabus, right? So you have the necessary information about exams and grading and so on. If the pandemic doesn't get worse, I will make the midterm exams, face-to-face exams. But if they say no, I mean you should do it online, then we will do it as in the previous semesters. But the final exam will be oral exam, and I'll do it online. Okay, so it doesn't matter, whether it is online or face to face for the oral exam. So before I continue, do you have any questions? Okay, so everything is understood then. All right. So let me start. So I will just follow the book mainly. And this is first time I teach this book, I mean this course. And I never took a course on probability theory. When I was an undergraduate, I took measure theory course. Theoretically, theoretical part is actually measure theory. So it is something I am familiar, common subjects of real analysis. But I wasn't actually comfortable with counting arguments and so on. But they are not big deal. I am sure you will not have hard time to learn those, counting stuff either. For the measure theory part, whenever we need a result from measure theory, I will state it, and they are also included in the textbook in the appendix. So I will just state what it is and so on. But I guess we won't have time to prove those results from measure theory. Maybe you may take a measure theory course later, or if you take a graduate analysis course, you will see that stuff in much more detail. All right, so let's start with chapter 1. I will also, put my lecture notes so that you may, get them. I will put them into internet, publish them on my web page. I will put the videos to the, YouTube also. So if you cannot take notes, properly, you can download my notes and then complete your notes. It is good to take your own notes, because reading someone's work, is not good in math. It doesn't help much to learn. You should write your own notes. Even if you cannot take notes here, download my notes, but then, from those notes, write down your own notes. Okay, that helps a lot. Otherwise, reading someone's work, okay, it's good, but it doesn't help much, to learn the subject. Okay, now let's start. So first we have the introduction. So there are two types of uh, experiments. First kind is with deterministic outcome. For example, okay, uh, when you heat water, it boils, right, at 100 Celsius under some, conditions. You have to be at the sea level and so on, but it boils at 100 centigrade degrees. So it doesn't change, if you repeat this experiment several times. As each time you get the same result. Maybe there might be slight changes, but not much. Second kind of experiments are, so these are experiments with deterministic outcome. Second kind, uh, experiments, so with random outcomes. Random outcome. For example, uh, tossing a coin, right? Uh, rolling a dice, and drawing a card from a pack, right? If you repeat these experiments, each time you may get a different result, right? Sometimes if you toss a coin, you will get sometimes heads or tails, right? And if the coin is an honest coin, it's not. If it's not fixed, then 50% it should come tail, 50% it should come out head, right? So these are experiments with random outcome, and probability theory deals with experiments of second kind, okay, not first kind. So probability theory deals with experiments of the second kind. In other words, experiments with random outcomes. Okay, so what's a random event? A random event is a possible outcome of an experiment whose occurrence is uncertain. Okay. Here an experiment will mean that not only natural phenomena but also the ones provoked by human beings. So some examples of random events are as follows. Let's see. The weather in a future time, right? Weather forecast. How will be the weather, right? Tomorrow or a week later. The outcome of elections. Well, I guess it depends, right? The change of winning at blackjack. Bu oyunu biliyor musunuz? Türkçe'de 21 veya batak diye biliniyormuş. Efendim? Öyle mi? Siz daha iyi biliyorsunuz, tamam. Population growth. The evolution of stock market. The evolution of stock market. Drawing a particular card from a pack. Okay. So probability theory, deals with experiments of this kind. These are some examples. Now let me tell you some more about randomness. So what is a mathematical description of randomness? Okay. Yok, şöyle mesela işte sinek 2'yi çekmek. Yani o random derken orada şeyi kastediyoruz. Hani bir tane kart çekiyorsun, o kartın işte ne olacağını bilmek gibi ya da ne bileyim yani evet, onun gibi. Okay. Given an event, let's say A, let NA denote the number of occurrence of A in N trials. Mesela işte kare onu çekmek için 20 kere kart çekiyorsun desteden gibi. Then of course NA will be between 0 and N, right? You try this N times and the number of times you have the event A, so you pick the particular card will be of course less than or equal to N, right? The ratio NA over N is called the relative frequency and of course this NA over A is less than 1 and it is always non-negative. So if the limit as n goes to infinity and A over A, if this limit exists, we denote it by PA. Okay, PA. Okay, and we say that the experiment has statistical stability. Okay, so probability theory deals with mathematical models of experiments with random outcomes having statistical stability. So you ask two things, for that experiment to be a subject of probability theory. It should have random outcomes, and the above limit should exist. In other words, the experiment should have statistical stability, right? So if you are, for example, dealing with, tossing a coin, we expect that, the limit, the above limit, for example, if A is the event that the coin will show head, that limit will be 1/2, right? If the coin is an honest coin. Zaten yani 1/2 çıkmazsa değil mi sorun çıkar. O zaman hile var demektir. Okay. Any questions so far? So we will so the probability theory deals with mathematical models of experiments with random outcomes having statistical stability. Okay, otherwise probability theory doesn't deal with that. uh, there are also many examples of such things in the nature, right? uh, Actually many things in nature are of this type: experiments with random outcomes and having statistical stability. uh, Even in physics, right? Quantum physics, mostly experiments there have random outcomes. uh, okay, sorusu olan var mı? Yoksa devam edelim. Basic concepts of probability theory. As in the case of any other theory, when you start uh, you know basics studying basics of a theory, you have to make a lot of definitions, right? Learn the objects of the theory and so on. So first you have to do a lot of writing, learn all the uh, basic concepts. So this is what we will do. First, let's see what is so-called sample space. So a sample space is a non-empty set of points denoted by uh, omega and its elements by omega. One of them is uppercase, the other one is lowercase. Okay, let's see what are these concepts in the experiments we have seen above. So examples. Uh, in the experiment of tossing a coin, our sample space has two elements, H and T, head and tail. Okay, so just two elements. One of them is H, representing head, T representing tail. In the experiment tossing a coin, when you roll a die, sorry, uh, the sample space is the number you see on the top. So it can be anything between 1 and 6. Okay. If you roll a pair of dice, then our sample space will be what? You roll two dice, so you may have 1 1, you may have 1 2, you may have 1 6. Here, uh, this entry represents the, so you have two dice, but you know which one is the first one and which one is the second one. So first one comes 1, the second one comes 1. Here first one comes 1, second one comes 6, and it goes like this: 2 1, 2 2, up to 2 6, and then 6 1, 6 6. Okay, so here our sample space is a set of ordered pairs. Okay, ordered pairs. So for example, here 3 6 and 6 3 are different. Usually it doesn't matter when you roll a pair of dice. One of them comes 3, the other one comes 6. It doesn't matter which one, but in this sample space, if you take your sample space this way, then it matters. Okay, uh, if you consider unordered pairs of dice, then you should declare it. Okay, so in that case, for you, AB will be same as BA. So it will be a quotient actually of this gadget by an equivalence relation. Okay, so it will be another set, not this one. Okay. A geometric one, shooting a round target with radius r. So in this case, so we have something like this. Okay, we have some, let's say, target like this, and you throw something, an arrow, or you take your gun and fire to this target and so on. In this case, our sample space is the disk with radius r. So you hit a point in this disk, so your sample space is the set of all the points in this disk. Okay, here we assume that each time you hit a point on this disk. Okay, all right. So what's a sample space? Sample space are the actually sets of results of the experiments, right? So you repeat an experiment, and the results of this experiment are elements of the so-called sample space. Okay. The other concept we will be dealing with, algebra of events. Okay. An event is a possible outcome of an experiment unless stated otherwise. uh, an event and its relation uh, yok realization olacaktı. Okay. We'll have the same, oops, the same meaning. The occurrence of an event may depend on the on that of on that of other events. Değil mi? Okay. Let me give an example of what we are talking about. Suppose two dice are thrown. Şöyle bir event tarif edelim. The eventimiz şu. The sum of the numbers shown up by each die is equal to 10. Diyelim ki event bu. Let x and y denote the number shown by the first and the second die respectively. So for us, it is important which one is the first die, which one is the second die. The number the first die shows is denoted by x, and the number shown by the second die is represented by y. Then our event E, so let E denote the event. Şöyle göstereceğiz onu. X plus y equals 10. Okay. Yani birinci ve ikinci zarda gelen sayıların toplamının 10 olması. Then E occurs, yani bunun gerçekleşmesi neye bağlı? If and only if and only if either E1 şu olacak. Bu ne demek? X4 and Y6 or E2, bu ne demek? X is 5 and Y is 5. Arada and var. And Y is 5. Or E3 X is 6 and Y is 4. Okay. Occurs. So E occurs if and only if either E1 or E2 or E3 occurs. Okay. In this case, we write this as şöyle yazacağız. The event E is equal to E1 or E2 or E3. Okay. Sorry. Yani E'nin olması bu üçünden birinin olmasına denk. Okay. Anlaşılmayan bir şey olursa hemen durdurup sorun, tamam mı? Notation. Bunun bir kötü tarafı, hani yazdığım şey küçük bir alanda oluyor. Her şeyi göremiyorsunuz. İki tane işte tahta olsa hani daha fazla şey yazmış olabilirim. Gerçi benim yazım da büyük olduğu için gene aynı miktarda olabilir de. Neyse. Biraz da notasyondan bahsedelim. Let A and B be events. Then A union B will denote event A or B. So the event either A happens or B happens will be denoted by A union B. Okay. And similarly, and A intersection B will denote the event A and B. Okay. So if the event that A and B happens simultaneously will be denoted by A intersection B. Okay. Both A should occur and B should occur. All right. Finally, A upper C superscript C will mean the complement of E, will mean the non-occurrence of E. So anything outside A, it means non-occurrence of A, right? A represents its the event A occurs. So A sub C will mean non-occurrence of A. Okay. More definitions. If let's say omega is a sample space, in other words, an arbitrary set of points, and abstract set of points, okay, which are considered as a possible outcome of an experiment, then any subset A of omega is called an event. So mathematical definition of an event is just a subset of the possible outcomes. Okay, any subset of the sample space is an event. Okay. In case of tossing a coin, our sample space was T and H. So what are the possible outcomes? Well, of course, when you toss a, what are the events? Events are the empty set. Another event is this one, and this one. So these are the events, okay? What kind of experiment can have this thing as as its set of events? For example, you toss a coin and you want that uh, it will show both head and tail, right? So that's not possible. That corresponds to the empty set. This corresponds that you toss the coin and tail comes. This corresponds to the event that you toss the coin and head comes, and you toss the coin and either head or tail comes. Okay, so these are the events. So sample space mathematically is just a non-empty set. Okay, any set. Event is a subset of that sample space. Event can be empty. Okay, there are some events which are not possible, right, to occur. Like you toss the coin and it will show both head and tail. That's impossible. So it will correspond to the empty set. Okay. All right. The non-empty collection of events will be denoted as uh, fancy A. Okay. Okay. Bu arada 20 dakikayı geçtik değil mi? Okay, let me stop here. Ara verelim.